In 1940, President Roosevelt asked Congress for 50,000 military aircraft. The military contractors said it couldn't be done. But Henry Ford looked at that impossible number and made a promise that made the entire aviation industry laugh. He said he'd build one bomber every hour. By mid-1944, he was doing it. The Willow Run factory in Michigan was producing bombers at a pace that changed the entire war. Not through heroics, not through genius design. Through something simpler and more powerful: industrialization, assembly lines, standardized parts, worker coordination. I went through production records, studied factory blueprints, and used AI to reconstruct the daily workflow of how these workers built a B-24 Liberator bomber every single hour at peak production.
What I found was a story about industrial genius that's been almost completely forgotten. Before we start, if you enjoy this video, give it a like and hit the subscribe button.
Charles Sorensen, Vice President of Production for Ford Motor Company, didn't say this promise casually. He'd walked through Consolidated Aircraft's facility in San Diego and seen how bombers were made. Workers built aircraft outdoors. Engines were attached to makeshift rigs. The sun heated steel differently than the cool hours of night, causing the metal to warp and shift. Two B-24 bombers coming off that line were never quite identical. The process was slow, handcrafted, imprecise. It was the opposite of everything Ford knew about manufacturing. Sorensen returned to Michigan and made his pronouncement to Henry Ford. "We'll build one bomber an hour." The aviation industry's response was to mock him. Aircraft manufacturers had spent decades perfecting handcraft methods. They had engineers, designers, and specialists. A car company? A company that built identical machines by the millions? It was absurd. One historical account said the aviation people considered the claim preposterous. But Ford wasn't bluffing. In March 1941, construction began on 975 acres of farmland owned by Henry Ford himself near a small creek called Willow Run, between Ypsilanti Township and Belleville in Michigan. The site was 35 miles west of Detroit, isolated from existing highway connections, sitting in the middle of Michigan farmland. The decision to build at Willow Run wasn't just about location. When Ford engineers realized they would be building complete bombers instead of just final assembly, the plant needed to be enormous. Willow Run would fabricate parts, assemble fuselages, build wings, install engines, test systems, and produce finished bombers all in one location. Architect Albert Kahn was brought in. Kahn had revolutionized factory design in America. He understood industrial flow. He understood how to make buildings that didn't just house production, but enabled it. Kahn designed a building over a mile long with dual parallel assembly lines running side by side. But there was a problem. If the plant stretched in a simple line, it would cross from Washtenaw County into Wayne County. Different tax rates applied. So Kahn and his team made a 90-degree turn halfway through the factory. The building bent like an elbow. This single design decision kept the entire operation inside Washtenaw County and saved enormous tax obligations after the war. The building went up in sections. As portions were completed, workers sealed them off with plywood partitions and moved on to the next section. 5 separate construction contractors were hired to accelerate the work. By September 1941, parts of the plant were already operational. By October 22, 1941, the entire facility was formally dedicated in a ceremony attended by Major Jimmy Doolittle of the U.S. Army Air Forces. The scale was literally beyond anything the aviation industry had ever seen. When completed, the main building sprawled across 3.5 million square feet of floor space. An adjoining airfield covered 1,484 acres with runways and aircraft hangars. The largest of these hangars could hold 20 B-24 bombers at once. The airfield had a hotel, a control tower, and a cafeteria. It was a complete industrial city built for one purpose: producing bombers. When Ford's engineers arrived at Consolidated Aircraft's San Diego facility to study the B-24 Liberator, they discovered something that changed everything about their approach. Consolidated didn't have updated blueprints, so Ford engineers did what seemed impossible. They went to San Diego and spent 4 months reverse engineering the entire B-24 from existing aircraft and incomplete sketches. Ford engineers produced 5 miles of blueprints per day. This blueprint effort revealed something critical. And here's where I need to acknowledge something that made Willow Run fundamentally different from every aircraft factory in America. Ford understood how to make identical parts. Car manufacturing depended on interchangeable components. Aircraft manufacturing worked the opposite way. Each bomber was slightly different. Variations were accepted. Craftsmen fitted parts to individual aircraft. Ford changed that completely. The B-24 Liberator was an engineering marvel and a manufacturing nightmare. At 67 feet long, with a 110-foot wingspan, it dwarfed anything aircraft factories had mass-produced before. It carried a crew of 10 and was powered by 4 Pratt & Whitney engines, each generating 1,200 horsepower. A combat-ready B-24, loaded with bombs and ammunition, weighed between 55,000 and 65,000 pounds, depending on the mission profile. It could fly 2,000 miles to German targets and return home. Consolidated Aircraft built beautiful B-24s. They just couldn't build them fast enough. Each bomber at Consolidated was a custom creation and took weeks between start and finish. Ford saw this and eliminated the entire approach. He would move the airplane, not the workers. A mechanical assembly line would carry the B-24 down a mile-long path. Workers stayed at their stations. As the bomber approached, they performed their specific task. Wings attached, fuselages riveted, engines mounted, hydraulic systems connected, electrical wiring threaded, control surfaces tested. When the bomber reached the end of the line, it was finished, ready to fly. This required absolute precision. Every wing had to fit every fuselage without modification. Every engine mount had to align with every engine perfectly on the first try. This demanded tooling, jigs, and fixtures unlike anything the aircraft industry had ever attempted. The line would produce 1 bomber every 100 minutes at peak efficiency. 4 bombers at different assembly stages moving down the line simultaneously. As one rolled off the end, another began at the start. The pace was relentless. Standardization made it possible. By December 1941, with construction complete, the factory was ready. Parts and subassemblies streamed in from Ford facilities across America. Workers were arriving by the thousands. The first production bombers were taking shape. Charles Sorensen's impossible promise was about to face reality. The factory that was supposed to build a bomber an hour couldn't build a bomber a day. Not at first. January 1942 arrived cold. Workers came in. The machinery hummed. And when the first month ended, Willow Run had produced 37 complete B-24 bombers. The aviation industry watched this number and smiled. Ford's promise was already looking impossible. The mockery started quietly. Some workers called the factory Will It Run. The name stuck. It became a joke. A running bet on whether the place could actually deliver what Sorensen had promised. But something different was happening behind the scenes. Ford's engineers weren't accepting failure. They were methodically destroying every problem in front of them. Bottlenecks were identified. Assembly sequences were redesigned. Tooling was refined. February 1942, 70 bombers had been produced. Double. March, 96 bombers. Still climbing. April, 146 bombers. The trajectory was clear. The factory wasn't failing. It was learning. The bigger challenge was happening at the employment office. America's skilled workers were disappearing. The Army was drafting men. Ford couldn't compete with the military for experienced metalworkers and machinists. So he did something radical. He hired women. By May 1942, women made up 15% of Willow Run's workforce. By 1943, with employment peaking at 42,000 workers, women represented roughly 1/3 of the total workforce. These weren't desk jobs. These were riveting positions, assembly stations, precision work requiring speed and absolute accuracy. The women at Willow Run earned the same 85 cents per hour as male workers doing identical jobs. and they turned out to be better at some tasks than their male counterparts. Riveting is detail work. It requires dexterity and sustained concentration. Research would later show that women often excelled at this type of assembly work. The factory understood this. It didn't segregate women into easier tasks. It trained them as riveters, as electrical specialists, as quality control inspectors. They became the backbone of the production line. By November 3, 1943, Willow Run had produced its 1,000th B-24 Liberator. The "Will it run" joke died that day. The factory wasn't struggling anymore. It was hitting rhythm. Workers knew their stations by heart. The line moved. Production was becoming routine. By September 1944, the factory completed its 6,000th bomber. 5,000 bombers later, and they were only just getting started on the real innovation. The engineers had been working on something, a breakthrough that would push production from fast to impossible. The center wing section of the B-24 was the most complex assembly point. Getting it wrong would break the entire fuselage. Ford engineers had analyzed every second of the process. They'd redesigned the jigs from scratch. They'd created fixtures so precise that components would snap together without adjustment. They'd discovered a way to make the most difficult part of the aircraft assembly routine. By mid-1944, the numbers stopped being theoretical. They became real. The factory produced one B-24 every 63 minutes. At the absolute peak, Willow Run rolled out 428 completed bombers in a single month. That's 14 bombers per day, 450,000 parts and 360,000 rivets in 550 sizes. Charles Sorensen's promise of one bomber per hour wasn't just reality. It was underselling what actually happened. Ford engineers had solved the unsolvable. The B-24's center wing was the most complex part of the entire aircraft. It had to be structurally perfect. It had to withstand enormous stresses. At Consolidated, building the center wing took days. Ford did the opposite. Engineers designed fixtures so precise that a prefabricated center wing section would snap into place without adjustment. A wing built in one location would fit a fuselage built somewhere else as if they were made for each other. Standardization made it possible. The more identical the parts, the faster they could be assembled. This single innovation changed everything. It wasn't just about the center wing. It revealed Ford's entire philosophy. Consolidated built beautiful, unique aircraft. Ford built identical aircraft, fast. And that made all the difference. The logistics required to maintain this pace were staggering. Ford had negotiated with nearly 1,000 subcontractors and suppliers across America. Wings arrived from one facility, fuselages from another, landing gear from a third. Electrical systems, hydraulic assemblies, engine mounts, each component came from a different source, arriving in sequence, positioned exactly when needed on the assembly line. Nothing sat in storage. Everything moved. The entire operation was choreographed like an orchestra. One missed note would break the rhythm. Getting 42,000 workers to and from the factory was itself a military operation. Willow Run sat 35 miles from Detroit with zero public transportation. The government established special bus routes. At shift changes, hundreds of buses arrived simultaneously. The logistics of moving that many people, coordinating their schedules, getting them home safely, then doing it again for the next shift. This was production engineering on a scale the American transportation system had never attempted. And in 1942, the federal government built the nation's second freeway, now I-94, to move workers and materials to the Willow Run plant. But something was ending. By late 1944, the military's priorities shifted. A new bomber was coming. The B-29 Superfortress was more advanced. It could fly higher. It carried a bigger payload. The Army Air Forces reduced B-24 orders. Willow Run's production line, which had accelerated month after month, began to slow. On June 28, 1945, Ford shut down the assembly lines. The machinery stopped. The conveyor belts went silent. Workers clocked out for the last time. The factory that had become the most productive bomber plant on Earth would make no more bombers. Nearly 9,000 B-24 Liberators had rolled out of Willow Run. The factory didn't die when the war ended. It transformed. Kaiser Frazer purchased the facility and ran automobiles down the assembly line for several years. General Motors later bought the building and manufactured transmissions there for decades. The factory that built bombers now built cars, but the methods spread globally. Every major American manufacturer studied Willow Run. Japanese companies took Ford's approach and refined it. Toyota developed just-in-time manufacturing, where parts arrived exactly when needed with no storage and no waste. Lean manufacturing emerged directly from principles Ford established on that Michigan assembly line. Walk into any modern manufacturing facility today, and you're looking at a system descended from Willow Run. The B-24 Liberator became one of the most widely produced heavy bombers of the war. But military historians overlook this. The people who built those bombers are forgotten. The riveting crews who worked 50 feet in the air during Michigan winters, the electricians who threaded miles of copper wire through fuselages, or the mechanics who tested engines. Sorensen said Ford would build one bomber per hour. By 1944, Willow Run nearly did exactly that, through discipline, standardization, and the principle that if you could build identical automobiles at scale, you could build identical aircraft at scale. And faster than anyone thought possible. But proof that manufacturing excellence could be industrialized. Willow Run closed in August 1945. The assembly line stopped. The factory that built 9,000 bombers shifted to cars, then transmissions, then sat idle. The airfield became a civilian facility, but the methods were remembered. Every modern manufacturing operation on Earth uses principles Ford proved at Willow Run. Standardized parts, continuous flow, worker training, quality control, synchronized supply chains, prefabrication. In 1941, these were revolutionary. They were the difference between building bombers that didn't matter and building them fast enough to change history. Charles Sorensen promised one bomber per hour. By 1944, Willow Run delivered. An automobile company became the most productive bomber factory on Earth. The 42,000 workers who built those bombers weren't famous, they're forgotten. But every assembly line you've ever seen, every factory where parts flow in rhythm and finished products emerge on schedule, descends from what they built on Michigan farmland in 1941. They proved that manufacturing excellence could be industrialized, that precision and speed weren't contradictions, that American workers could accomplish what seemed impossible.
If you like this deep dive, subscribe and give this video a like. And let me know in the comments what I should reconstruct next.